Welcome back to Math Solver 1117. Today we will solve an interesting geometry problem, that is find the area of semicircle. First of all, we will draw the diagram. That is, this is a right angle triangle and this right angle triangle have a semicircle like this is a semicircle and this is the center of this circle. Let's suppose this is A and this point is B, this point is C. You have to find the area of this circle, the area of this semicircle. Now the next thing is the length of this side is also given, that is 3 and this side is 2. And now this point is B and where the semicircle touch this right angle triangle, this point is D. And these points are E and F. Now we can also join A and D. This will be the radius, this will be the radius, this will be the radius. These are the radius points. And now first of all we can see, according to the tangent rule, if two tangents are drawn, these are two tangents FD and FB are drawn to one circle they form same external point. This is their external point. External point condition is they are congruent. This is the condition that both are congruent. It's mean if this side is 3, this side is also 3. So because these are tangent FD and FB to this circle, that's why this side and this side are equal. Now in the next step we will consider this semicircle and this is a right angle triangle. This is 90 degree. First we find the value of the base of this triangle. So according to Pythagoras theorem, so focus on a right angle triangle BFE. You will see that hypotenuse square equals base square plus perpendicular square. You have to find the base value. So base square equals hypotenuse square minus perpendicular square. You know that hypotenuse is 3 plus 2, that equals 5. So 5 square minus perpendicular, that is 3 square. So 25 minus 9, that is 16. So you get base square is 16. It's mean that base will be equals 4 because we take the square root on both sides, then base is 4. Now after finding base is 4, it's mean this whole side is 4. We can easily find the value of r. Now consider that there is also a right angle triangle and this angle is 90 degree. So this will be the base, and now first of all we have to find the CE. So BE equals BC plus CE. So CE equals BE minus BC. Now the value of BE, this whole equals 4, and BC is R plus R, that is 2R. So CE equals 4 minus 2R. Now when you take this triangle, this right angle triangle, so focus on right angle triangle BAE, DAE. You can see this is the base, this is perpendicular, and this will be the hypotenuse. So hypotenuse is this one. R plus 4 minus 2R, it's mean 4 minus R. Hypotenuse is 4 minus R, base is R, and perpendicular is 2. Now we can easily find the value of R by applying the Pythagoras theorem. So on triangle BD ADE, we will apply Pythagoras theorem. So this side is 4 minus R square equals R square plus 2 square. Now we get 16 minus 2R plus R square equals R square minus plus 4. Now you can see R square and R square are cancelled out. 16 minus 4 equals 2R. 16 minus 4 is 12 equal 2R, which implies that R equal 12 by 2, that is 6. So value of radius is 6. Now after finding the radius value, we can easily find the area of semicircle. So radius equals 6. Now the area of semicircle, semicircle area is 1 by 2 pi R square. Now the value of R is 6. So 1 by 2 pi and 6 square, that is 36. So 36 pi by 2, it's mean 18 pi. So this is the answer. Now the area of this semicircle is 18 pi. If you found this video helpful, subscribe Math Solver 1117 and also hit the bell icon to get notification for all upcoming videos. In the next video, we will solve another interesting question that mostly asked in Olympiad math and many university entrance test exam. Stay tuned. Best of luck for your exam.